Hi and welcome back to class of Design of Machine Elements. I am Hitesh Raiyani, Assistant Professor at LJ Institute of Engineering and Technology. This is lecture 30, example V-belt drive. The learning outcomes of this lecture is to learn the example of V-belt drives. In previous lectures we learned the theory of V-belt drives. Now in these lectures we learn one examples based on the V-belt drive. So consider one problem, that is a compressor requiring 90 kilowatt is run at about 250 rpm. The drive is by V-belt from an electric motor running at 750 rpm. So here a power rating is given 90 kilowatt and a compressor runs at 250 rpms and V-belt drives is used for this, and electric motor running at 750 rpm is given. The diameter of the pulley on the compression shaft must not be greater than 1 meter, while the center distance between the pulley is limited to 1.75 meters. So center distance between the pulley is x is equal to 1.75 meter is given. The belt speed should not exceed 1600 meter per minute. So here V is given, that is 1600 meter per minute. Determine the number of V belt required to transmit the power if each belt has cross-sectional area of 375 mm square. Here a cross-sectional area is given, that is A is equal to 375 mm square. The density is 1000 kg per meter cube and allowable tensile stress of 2.5 megapascal is given. The glue angle of the pulley is 35 degrees. The coefficient of frictions between belt and pulley is considered as 0.25. Calculate also the length required of each belt. So in these problems we have to first calculate the number of V-belt required according to our condition. So here the power rating is given 90 kilowatt, and for that we have to calculate the how many number of V-belt we require to satisfy this condition. So to calculate the number of V-belt, we have to first calculate the power transmitted by one belt, and then we have a total transmitted power 90 kilowatt. So we can calculate the number of belt required, and also we have to calculate the length required of each belt. So first of all we collect the data given, that is given data is P is 90 kilowatt, that is 90 into 10 raised to 3 watt. N2 is given, that is 250 rpm, N1 is 750 rpm, D2 is 1 meter or X is given 1.75 meter. Here the belt velocity V is given 1600 meter per minute. So if we convert into meter per second, it will be 26.67 meter per second. Belt cross-sectional area A is given, that is 375 mm square, or you can say 375 into 10 raised to minus 6 meters square. Rho density of belt is given, that is 1000 kg per meter. Sigma is given 2.5 megapascals, or you can say 2.5 Newton per mm square. The pulley glue angle is given, that is 2 beta is equal to 35 degree. So you can say that beta is equal to 17.5 degree. And Poisson's ratio given, nu is equal, coefficients of friction is given, nu is equal to 0.25. So this is the given data, and we have to calculate how many number of belt is required for this design problems, and also we have to calculate the length of the belt. So consider first the given configurations of V-belt drives according to our problems. Here the X is the 1.75 meters, and R1 is the motor pulley radius, and R2 is the compression pulley radius. So we have to first calculate the diameter of pulley, compression pulley. So here N1 is equal to N2. n1 upon n2 is equal to d2 upon d1. We know the velocity ratio, and according to that we have to calculate d1 is equal to d2 into n2 divided by n1. So here d2 is given 1, that is the diameter of compression pulley, and n2 is given 250 and n1 is given 750. So if we place all this value, we get d1 is equal to 0.33 meter. Now next is from this given configurations we have to calculate the value of alpha. So according to these configurations, if we see the triangle O1M O2, then sin alpha becomes O2M divided by O1 O2 distance. So O2M we know that it is nothing but the R2 minus R1 or D2 minus D1, and O1 O2 distance is the center distance, that is X. So if we have used these equations, we get the sin alpha value is 0.1914, and if we take sin inverse this value, we get the alpha is equal to 11.04 degree. So we can calculate now the value of theta. So angle of lap on the smaller pulley, you can see that on smaller pulley or motor pulley, the angle of lap, that is theta, is nothing but the 180 minus 2 alpha. So now we have a value of alpha, so we can calculate the value of theta. So theta is 180 degree minus 2 alpha. So we have to place the value of alpha is equal to 11.04 degrees. So we get the theta is equal to 157.92 degree. If we convert into radian, then we have to multiply by pi by 180. So if we multiply by pi by 180, we get theta is equal to 2.76 radian. Now next is, we know the mass of bed per meter length. So we know that mass is equal to area into length into density. Here length we have to consider per meter length. So when length is considered is 1 meter, and area is given, that is 375 into 10 raised to minus 6. Length we consider as 1 meter, and density is also given in our problem, that is 1000 kg per meter cube. So if we place all this value, we get the mass is equal to 0.375 kg per meter. Now we can calculate the centrifugal tension, that is Tc is equal to mv square. So m we calculate here, that is 0.375 kg per meter, and v is given in our problem, that is 26.67. So we get the centrifugal tension is equal to 267 newtons. Now we have to calculate maximum tension in the bell. So maximum tension in a bell, we know that T is equal to sigma into A. Here both value we given in our problem. So sigma is given 2.5 Newton per mm square, and A is given 375 mm square. So we get the T is equal to 937.5 newtons. Now we have a value of maximum tensile T and centrifugal tensile Tc. So we can calculate the tensile in the right side, that is tensile in the tight side of the bell, that is equal to T1 is equal to T minus Tc. So T here is the 937.5, and Tc here we calculate 267. So if we place all this value, we get the T1 is equal to 670.5 Newton. So this is the tensile in tight sides. Now we have to also calculate the tensile in slack side to calculate the power. So let's consider T2 is the tensile in slack side of the bell. So as we know the relations between T1 and T2, that is 2.3 log T1 upon T2 is equal to nu theta into cosec beta. Here the drive is V belt drive, so we have to use the V belt drive equations, that is given in our presentation slide. 2.3 log T1 upon T2 is equal to nu theta into cosec beta. So now we have a value of T1, nu, theta and cosec beta. So we can calculate the value of T2. So we have to place the value of nu, theta and cosec beta. So we get value 2.3 log T1 upon T2 is equal to 2.295. So we get log T1 upon T2 is equal to 2.295 divided by 2.3. So we get answer is 0.9976. So in this equations, if we take anti-log of this value, that is 0.9976, we get T1 upon T2 is equal to 9.95. And we have a value of T1, so we can calculate the T2 from this equation. So T2 is T1 divided by 9.95, and value of T1 it is 670.5. So we get T2 is equal to 67.4 newtons. So now we have both the value T1 and T2, and V is given in our problem. So we can calculate the power transmitted by one bell. So next is power transmitted by one bell. To calculate the number of V bell, we first calculate the power transmitted per bell. So we know the equations of power transmitted per bell, that is P is equal to T1 minus T2 into V. So here we calculated T1 and T2, and V is given in our problem. So we can place the value of T1, that is 670.5, T2 that is 67.4, and V is given 26.67 meter per second. So we get the power is equal to 16085 volt, or if you convert into kilowatt, that is 16.085 kilowatt. So this is the power transmitted by one bell, and here our capacity of the drive transmitted rated power is given 90 kilowatt. So we have to calculate the number of V bell is equal to total power transmitted divided by power transmitted per bell. So total power transmitted is given, that is 90 kilowatt, and power transmitted per bell we calculate here, that is 16.085 kilowatt. So if we place the value of total power transmitted 90 and power transmitted per bell is equal to 16.085, we get the answer is 5.6, say 6. So 6 number of bell required according to our configurations. Now next we have to calculate the length of bell. So for the length of each bell, we have equations. L is equal to pi into R2 plus R1 plus 2x plus R2 minus R1 square divided by x. Here R2 and R1 is the radius of pulley, and x is the center distance of pulley. So all this value we have. So we can place these values to get the length of bell. So here we have to place R2 is equal to 0.5, R1 is equal to 0.165, and x we have to place 1.75. So we get the length of bell is equal to 5.654 meter. So this is our second answer. So in these lectures we learned V bell drives problems, and in these problems we calculated how much the number of V bell required according to the given power rating, power transmitted capacity of V bell drive, and number of and the length of each bell. Thank you.